All right, today we are diving into something that feels a little like science fiction, but it's very, very real. We're talking about a new kind of AI that's not just powerful, but in a way, it's alive. These are systems that can adapt and change on a level we've just never seen before. Welcome to the world of liquid neural networks.
Now that is a bold statement. What it's really saying is that we're looking at an AI that doesn't just stop learning after its initial training. No, this thing can literally rewrite its own internal programming while it's working. It's learning from new stuff in real time. So here's the fundamental difference. The incredible models we have today, like what's behind ChatGPT, are brilliant, no doubt, but they're static. The best way to think about it is like a finished book. Once it's printed, the story is set. All the knowledge is locked in. Liquid AI, or LNNs, are the complete opposite. They're like a living book that writes its own new chapters as it goes out and experiences the world. So where did this absolutely wild idea come from? You might think it was dreamed up in a lab with a massive supercomputer, but nope. The inspiration came from one of the simplest, tiniest creatures on our entire planet. That's right, the blueprint for this next-gen AI comes from this little microscopic worm, C. elegans. And it turns out its nervous system is an absolute marvel of natural engineering and incredible efficiency. And this is the part that is just going to blow your mind. Our brains have, billions of neurons. This worm has just 302. That's it. The whole system. It's such a small number that scientists have mapped out every single connection. So the real question is, what can you actually do with a brain that small? Well, as it turns out, a whole lot. With just those 302 neurons, this little guy can navigate its world. It can find food, it can mate. But here's the most important part. It adapts. Its brain isn't some fixed circuit board. It can actually reconfigure itself on the fly when it encounters something new. And that amazing ability to do so much with so little is the core idea behind liquid neural networks. Okay, so that's the why, the inspiration from nature's tiny genius. Now let's get into the how. How exactly did engineers take the lessons from this worm and turn them into a brand new kind of artificial intelligence? At its core, this is what an LNN is. It's an AI that isn't frozen in time after its training is done. Its internal guts, the parameters and connections that make it think, are, well, liquid. They can change and flow as new data comes in, allowing the AI to adjust its behavior long after it's been deployed. This chart really breaks down the key differences. So traditional networks, they process information in these separate, discrete steps, kind of like flipping through the panels of a comic book. LNNs, on the other hand, see time as a continuous, unbroken flow, more like a river. And because their internal parameters are dynamic, not fixed, the result is this incredible, continuous adaptability that older models just can't touch. Okay, so this isn't just some cool academic idea. This ability to continuously adapt has massive, game-changing implications for how we can use AI out in the messy, unpredictable real world. For instance, imagine a robot working in a factory. A traditional AI might just fail if it comes across a box it's never seen before. But a robot with an LNN for a brain could adapt its grip, change its strategy, and learn how to handle that new object right there on the spot. No need to stop and retrain the whole system. Or think about healthcare. An LNN could take in that constant stream of data from your smartwatch or other wearable. It could learn the unique patterns of your body and adapt its analysis as your health changes over time. This could lead to truly personalized, proactive health monitoring that's always learning about you. And what about finance? We all know how unpredictable markets can be. An LNN could power financial models that don't just look at old data, but constantly adapt to breaking news and sudden shifts in market sentiment. This could potentially build systems that are way more resilient when those unexpected shocks hit the system. But let's be real here. While the promise of this technology is enormous, it's still pretty early days. And there are some really significant hurdles that researchers are still trying to figure out how to jump over. So the road ahead is definitely steep. For one, these things are computationally expensive. They take a ton of horsepower to run. Training them can be, well, let's just say a bit unstable. And scaling them up to the massive size of today's big language models is a whole other major challenge. In fact, to really unlock their full potential, we might even need to invent entirely new kinds of computer chips that are designed to work more like a biological brain. So what's the big takeaway from all this?
Liquid neural networks are asking us to completely shift how we think about AI. We need to move away from seeing it as just a static tool that we build and use, and start seeing it as a dynamic learning partner, a system that can actually grow and evolve alongside us. And that single shift, well, that could change absolutely everything about our future with intelligent machines.